Hello friends, today we will see Rolle's theorem, where it is applicable and how it is applicable. We will see, I just named Rolle's theorem as 3 plus 1 theorem. That means if three conditions are satisfied, then the fourth will happen. What are these three conditions? See here. If a function is continuous in a comma b, what is that? Function is continuous in closed interval a comma b. If function is differentiable in open interval a comma b, and fa is equal to fb. If these three conditions are happening, then f dash x, that means the value of x which is making its derivative 0, and that value we take as c. So we can say f dash c is equal to 0 and c should be between a and b. Then the Rolle's theorem is completely verified. So once again I want to say, if function is continuous, it is differentiable, f is equal to fb, then f dash c is equal to 0 and that c should be between a and b, and the Rolle's theorem is verified. So for the application of the Rolle's theorem, firstly we have to see whether the function is continuous or not continuous. You just see all the polynomial functions are continuous everywhere. They are differentiable. What we need to do? We need to just take fa and fb. Suppose question number 1, I want to take verify Rolle's theorem for fx is equal to sin x plus cos x minus 1 in 0 to pi by 2. We will see sin and cos functions are continuous everywhere. So definitely it will be continuous in 0 comma pi by 2. One thing you have to write, you have to just write that sin and cos is continuous everywhere. So this is continuous in 0 comma pi by 2. You need to write, don't skip these steps. It is differentiable. How? Just I am telling you a technique, very easy technique. You differentiate the thing. If you find f dash x, it is coming out to be cos x minus sin x. Why? Differentiation of sin x is cos x and that of cos x is minus sin x, and it is differentiable everywhere. What does this mean? Differentiable? Its derivative is defined at all values of x. What is derivative? F dash x. So it is differentiable in the given interval. So it is differentiable in interval 0 to pi by 2. This is open interval. In between that, closed means the external boundaries are also included. Now we have to check whether fa is equal to fp or not. Now fa, that is f0, is going to be sin 0 is 0, cos 0 is 1 minus 1 coming out to be 0, and fb, that is pi by 2. Sin pi by 2 is 1 plus cos pi by 2 is 0 minus 1 coming out to be 0. So fa is also equal to fb. So the first three conditions are met. So we can say that f dash x will be 0 and that value of x which we term as c will be between a and b. We will see it. Now f dash x is cos x minus sin x. We term that point as c. The value of x we take is as c. So f dash c, you just write c in place of x. So it is cos c minus sin c is equal to 0. We have to get the value of c. So it is coming out to be like that, sin c is equal to cos c. We can just write tan c is equal to 1. Why? Because I divided both sides by cos c here, so it is 1. And tan is 1 at 45 degree. So c is pi by 4. Definitely you see that pi by 4 is lying between 0 and pi by 2. So this pi by 4 is between 0 and pi by 2. So we can say Rolle's theorem is verified. So you just got how to write. Firstly write the continuity, then differentiability, then fa is equal to fp, then just differentiate and put c in place of x, put it equal to 0 and get the value of c, and you see that the value of c is between the given interval. The Rolle's theorem is verified. In question number 2c, verify Rolle's theorem for ex sin x minus cos x in that interval. You see here, e to the power x is continuous everywhere and sin and cos is continuous everywhere. So the product of e to the power x into sin x minus cos x is continuous everywhere. So it is continuous in the given interval. You need to just write it is continuous in the given interval, that is e to the power x sin x minus cos x is continuous in given interval pi by 4 to 5 pi by 4. This closed interval 3. Now if you just differentiate this thing, I said you, if you write fx is equal to this thing, f dash x is going to be e to the power x, differentiation of this is cos x plus sin x minus cos x, differentiation of e to the power x is e to the power x. What I did here, I just applied u into v. I took this as u, that is v, and I differentiated. You see that this is defined for all values of x. Why it is defined? People just ask, how can you say that this is defined? This is defined because denominator is not coming out to be 0. The thing inside the even root is not coming out to be negative. No denominator is involved, so it is defined all the way. So we can say this is derivable in the open interval pi by 4 to 5 pi by 4. You just need to write that only. Now you have to take fa is equal to fb. So fa, that means f pi by 4 is going to be e to the power pi by 4 sin pi by 4, we know 1 by root 2, minus cos pi by 4 1 by root 2. Definitely it is going to be 0. All the time it won't be 0. In the earlier question we saw that fa was 0. It can be anything. It can be 3, fb can be 3, it can be 5, it can be anything, not necessarily 0. Luckily it is coming out to be 0 here. Now f 5 pi by 4, that is fb we are finding. Fb is e to the power 5 pi by 4 and sin 5 pi by 4 is minus 1 by root 2 and this is minus 1 by root 2 cos 5 pi by 4. Why minus? You know that it is lying in the third quadrant. In third quadrant, sin and cos both are negative. Ultimately it's going to be 0. So the first three conditions of the Rolle's theorem are met here. Now go for f dash x. F dash x, we got it here. So f dash c will be, you just write on simplification, it is coming out to be e to the power c cos c plus e to the power c sin c plus e to the power c sin c minus e to the power c cos c. This is getting cancelled. So what you are left with, 2 e to the power c sin c is equal to 0. As it is not 0, so we can write just sin c is equal to 0. Where sin is 0? People say it is at 0 degree, but we have to find an interval between the given interval where the f dash c is 0. So at sin pi 180 degree also it is 0. So c is pi. Now definitely see that pi is lying between pi by 4 and 5 pi by 4. So pi is lying between pi by 4 and 5 pi by 4. So Rolle's theorem is verified here. See, in question number 3, we have to discuss the applicability of the Rolle's theorem for this function, mod function. See, fx is equal to mod x and the interval is -1 to 1. You will check by the basic continuity theorem that it is continuous. So we can just write it is continuous in -1, 1. Okay, if you draw the graph of this thing, no break is there. It is definitely continuous, not a problem at all. Now we have to check whether it is differentiable or not differentiable. So we have to break this function into its subparts, taking the definition of mod into consideration. So fx is coming out to be x if x is positive, that means greater than equal to 0. Okay, and it will be minus x if x is less than 0. So we got the value of fx after removing the sign of modulus. Now if we just differentiate this f dash x, it will come out to be 1 and -1 if x is greater than equal to 0, if x is less than 0. You just see that at x is equal to 0, it got different values. That means left hand derivative is not equal to right hand derivative. So it is not differentiable at x is equal to 0. At 0 is one interval between -1 and 1. So this is not differentiable. It is not differentiable at x is equal to 0. That means in the interval -1 to 1, it is not differentiable. So no question of applicability of Rolle's theorem. So Rolle's theorem is not applicable because the conditions are not met. So we can directly write Rolle's theorem is not applicable. See, in question number 4, it is given that function fx is equal to x cube minus 6x square plus ax plus b. Rolle's theorem holds. What does it mean? We need not have to prove that whether Rolle's theorem is applicable or not. We have to take it granted that Rolle's theorem is applicable. That means this is continuous, that is differentiable, and fa is equal to fb. We need to take the conditions as granted. So if we just write fa is equal to fb, that means f1 is equal to f3. This is giving us, if we put 1, this is 1 minus 6 plus a plus b is equal to fb. 3 we are putting, that is 27 minus 6 into 9, 54 plus 3a plus b. So we can get the value of a and b from the given conditions. Definitely you see here that b is cancelled out here. We will get the value of a. What is that? This is coming out to be -5 plus a is equal to -27 plus 3a. So it is coming out to be 2a is equal to 22. So a is coming out to be 11. Now we need to find fb. B, value of the b. A we got it because fa is equal to fb. Now f dash c. That means if we just differentiate this thing, this is 3x square minus 12x plus a. We just put the value of x because f dash c has to be 0. So you just put c is given 2 plus 1 by root 3. That is 3 into 2 plus 1 by root 3 square minus 12 into 2 plus 1 by root 3 plus a is equal to 0. If you solve, you will again get the value of a, which will be again 11. So the value of a is 11 we are getting. What we are getting, that b is getting cancelled out. B is not involved in the process of differentiation, and so we can say that it is applicable. it is verified for all values of B. So we can write that A is 11 and B is all real values. So we got the value of A and we got the value of B. Just we applied the Rolle's theorem and got the values. Hope you are understanding Rolle's theorem very well. Thank you.
For useful videos, subscribe to my channel Santosh Pembi on YouTube or log on to my website www.mathsonphone.com. Thank you.